All right, we've made it to the problem set. Now, again, you should not simply be watching the video and recording the solutions. You should be attempting the problems before viewing the solution. Problem 1. Select all the equations that represent the hanger. So on my hanger, I've got on the left side 3 weights, each labeled with an X. And on the right side, I've got 6 of these squares, which I can pretty safely assume each have a value of 1 unit. So let's look at our first one. X plus x plus x. Yeah, x plus x plus x is equal to 1 plus 1 plus 1 plus 1 plus 1 plus 1. And definitely have 1 added together 6 times. So this one does actually represent the hanger. The next one, x times x times x times x equals 6. So you might be tricked into selecting this one because certainly on the right side you do have 6 and on the left side you have 3 x's, but they are being combined and over here it shows them being multiplied. So if this said x plus x plus x as it did in the first equation, it would be right, but x times x times x is not correct. All right, the next one, 3 times x equals 6. Yeah, 3 times x, which is the same as x plus x plus x, equals 6, and on the right I have 6, so this is correct. The next one, x plus 3 equals 6. Well, the right side is correct, but the left side is not. This is 3 times x, not 3 plus x, so that is not correct. And our last one, x times x times x. Well, this is just like the second one. It is the left side of the equation is x plus x, not times. So that one is not correct. All right. Problem 2. Write an equation to represent each hanger. So these are balanced hangers. So I know there's an equal sign in the middle of the left and right sides on each one. So I just need to write an expression that represents the weight on each side of the hanger. So for A, I've got 2 x's on the left, so 2x equals, and on the right I've got 3 unit weights, so 2x equals 3. For hanger B, on the left side I've got a combination of x and 1.3. So on the left side is going to be W plus 1.3, and on the right side I've just got a weight of 2.7. Diagram C, on the left side I've got 3 weights that have a value of y, so 3 times y, and on the right side I have a weight with a value of 5.1, so 3y equals 5.1. And for diagram D, on the left I've got a weight with a value of z, and a weight that has a value of 1/3. So on the left side I have z plus 1/3, and on the right side I just have a weight with a value of 1/2. So z plus 1/3 equals 1/2. Moving right along. Problem 3. Write an equation to represent the hanger. Alright, so my hanger, it's balanced, so it is going to be an equation. On the left I've got 2 x's. So 2 times x, and on the right side I've got a large shape that has a value of 14.62. So my equation is 2x equals 14.62. Explain how to reason with the hanger to find a value of x. Well, when it says find the value of x, it means the value of 1x. So I just want to know what one of these x's equals. So I could split the left side into 2, but then I've also got to split the right side into 2. Let's see. This isn't too hard to do in my head. 14 divided by 2 is 7. 0.6 divided by 2 is 0.3, and 0.02 or 200ths divided by 2 is 1. So each half of this has a value of 7.31. So I would say I'm going to split both sides into 2 equal parts. And the result is that I get x is equal to 7.31. Each of these x's is equal to 7.31. Explain how to reason with the equation to find the value of x. So my equation was 2x equals 14.62. And I just want to know what 1x is. So I would have to divide this side by 2. And to keep my equation true, if I divide one side by 2, I've got to divide the other side by 2. So 2 divided by 2 is x, just 1x. And 14.62 divided by 2, I've already done that, is equal to 7.31. So my explanation is divide both sides by 2. Again, that's really our golden rule of algebra. Whatever you do to one side of an equation, you must do to the other side of the equation. All right, problem 4. Andre says that x is 7 because he can move the 2 ones with the x to the other side. Do you agree with Andre? Explain your reasoning. No, Andre. Because in order for the hanger to represent an equation, it has to stay balanced. And if I just take these 2 and move them to the other side, my right side is now going to become heavier and my left side becomes lighter, and it's no longer going to be balanced. It can no longer be thought of as representing a true equation. So explain my reasoning. If I'm explaining it using the diagram, I would say moving 2 units from the left to the right will unbalance the hanger. And it will no longer represent a true equation. So my answer, I guess I better put that there, is no. Now, if I really did want to find out what the value was, I could think, I don't want to just move 2 from one side to the other side. I want to take away 2 from the left side. And then to keep my hanger balanced, I would have to remove 2 from the right side, and then I would see the actual solution to this equation is x equals 3. All right. Moving right along, problem 5. Match each equation to one of the diagrams. Ooh, we have kind of a tape diagram here for each of these. 12 minus m equals 4. That kind of looks like this one to me, because if I have 12, and the top is equal to the bottom, and I take away m from that 12, I'm left with 4. So I believe that is equation B. So 12, take away this m equals 4. Equation 2, 12 is equal to 4 times m. That looks a lot like D. Here's 12, here's 4m. So this really shows me 12 is equal to 4m. So that's D. How about 3? M minus 4 equals 12. That looks like this one here. Here I show that m is equal to 12 plus 4. So I could think of this as if I have m and I take away the 4, I'm left with the 12. So this looks like A. And my last one, m divided by 4 equals 12. And that looks like C. I'm showing that m is equal to 4 groups of 12. So if I take m and split it into 4, each one of the fourths is going to be equal to 12. So that is C. All right. the area of a rectangle is 14 square units. It has side lengths A and B. Given the following values for A, find B. So if we just want to make a diagram to help us visualize what they're saying, we've got a rectangle that is 14 square units, and we're saying the length of one side is A and the length of the other side is B. And knowing what I know about areas of a rectangle, this means that A times B must equal 14. So in each of these problems, I'm given the side length of A. So this means for number 1, that means 2 1/3 times B has to equal 14. For number 2, for 4 1/5 is equal to A, this means 4 1/5 times B has to equal 14. And for 3, where A is 7/6, that means 7/6 times B must equal 14. So, I need to figure out what B is. I'm going to choose a different color. I want to figure out what B is in each of these. So again, I'm thinking about this. If I have two numbers multiplied together equal a third number, then this third number divided by either of these must equal the other. So I know I can find B by dividing 14 by 2 1/3. So I need to do 14 divided by 2 1/3. This is a throwback from Unit 4. So first I need to convert my numbers into improper fractions, because the way I do fraction division is keep, change, flip. So 14 just becomes 14 over 1. 2 1/3. 2 times 3 is 6, plus 1 is 7. So this becomes 7/3. And then I'm going to do my keep, change, flip. So I keep the first number, change division to multiplication, and I flip my second number. And at this point, I always like to simplify before I multiply. 14 and 7 can both be divided by 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. And now I can multiply straight across. 2 times 3 is 6. Over 1 times 1 is 7. So for this one, B is equal to 6. All right, let's move on to this next one. So I can solve this in a similar fashion. If 4 1/5 times B equals 14, then B is going to be equal to 14 divided by 4 1/5. I'm going to find myself some room to do this here. Let me move it down here. So I need to do 14 divided by 4 1/5. Again, I'm going to change everything to improper fractions. So 14 over 1 divided by 4 times 5 is 20, plus 1 is 21, so this is 21/5. Now I can do my keep, change, flip. So 14 over 1 times 5 over 21. And again, I want to simplify before I multiply. 14 and 21 can both be divided by 7. So 14 divided by 7 is 2. 21 divided by 7 is 3. And now I can continue. 2 times 5 is 10. 1 times 3 is 3. So the solution here is 10 1/3. Or if I want to convert it to a mixed number, 3 goes into 10 3 times with a remainder of 1/3. So for problem 2, B is going to equal 3 1/3. All right, now I am up to problem 3, where A is equal to 7/6. Again, if 7/6 times B equals 14, I can figure out what B is by dividing 14 by 7/6. So 14 divided by 7/6 is going to equal B. Convert everything into improper fraction. 7/6 already is, but 14 we're going to rewrite as 14 over 1. And I'm going to do my keep, change, flip. So 14 over 1 times 6 over 7 equals b. I'm going to simplify before I multiply. 14 divided by 7 is 2. 7 divided by 7 is 1. And now when I multiply straight across, 2 times 6 is 12. Over 1 times 1 is 1. So in this case, b equals 12. And here we go. Let's make these a little bit easier to find here. All right, last one, problem 7, and this is a throwback to Unit 3 where we were talking about percentages. Problem 7. Lynn needs to save $20 for a new game. How much money does she have if she has saved the following percentages of her goal? So her goal is $20. And in each of these, it's giving you the percentage of that goal that she has saved. So we just need to know 25% of $20, 75% of $20, and 125% of $20. And all sorts of ways you could solve this. One of them is I could think about what were these benchmark percentages. I know that 25% had a benchmark equivalent of 3/4. We wanted to convert it to a fraction. 75% was 3/4. And 125%, this is 100% plus 25%. So 100% would be the full amount, and then 25% would be another 1/4. So I could use the I could use the benchmark fractions to help me solve that. I can find 1/4 of 20. If I divide 20 by 4 equals 5. So 1/4 of 20 is 5. So it could be $5. 3/4, well, I know 1/4 is 5. So 3/4 would be 3 times as much. So 75% of 20 would be $15. And then 125%, well, that's going to be 1 times the amount, which is $20, plus 1/4 of the amount, which we already determined was $5. So this would be $25. I could also just use multiplication. 25% is 2,500, 2,500 hundredths, which in fraction decimal form is 0.25. So I could have done 0.25 times 20, and I still would have found that it was 5. Here, 75%. 75% is 7,500 hundredths, which is in decimal form 0.75. So I could have done 0.75 times 20. I still would have gotten 15. And here, 125%, that's 125 hundredths, which is 1 in 25 hundredths, which is 1.25. So I could have multiplied 1.25 times 20, and I still would have gotten $25. So a lot of different ways you can solve percentage problems, and I would just use whatever makes sense to you. Lots of times I like to just use what's most efficient, and actually in this case, reasoning using the benchmark fractions is, I think, easier to do than doing the conversion to a decimal and multiplying, because I can do this easily in my head. But that's up to you.